Welcome to the session Direct Routing with Microsoft Teams. My name is Thomas Binder. I'm a Senior Program Manager in the Teams product group. Before we go into the content, let's do a little bit of housekeeping about this deck. If you're looking for any additional resources, go to aka.ms/Teams Academy. You can find there a lot of additional trainings. If you have any feedback specifically to this session, if you have any questions on the content that we are discussing, please go to aka.ms/Teams community, create a new post there, and use the label IT Pro Training so we can easily find it and reply to your questions. If you have feedback for the feature, please go to microsoftteams.uservoice.com where you can share ideas and vote on existing ideas. Please also note that Teams and Office 365 evolve constantly. So get sure that you visit on a regular basis our blog at aka.ms/Teams blog so that you learn the latest and greatest. Also, we will be refreshing this training whenever it is required. You can see on this slide when this version of the training was recorded, and this should also give you an indication how up to date the content might be at the time you're watching it. In order to get out most of the session, there are a couple of things that you should already be familiar with. You should already have a good understanding of Teams, how to deploy it, how to configure it, and how to manage it. And you should have had some exposure to phone system so that we can jump right into the direct routing here, though we'll give a very brief introduction. The key learnings after this session that we want you to have is understanding that direct routing allows you to use your existing PSTN connectivity, being existing trunks or being a PBX that you have already. That session border controllers, this component that is required for direct routing, can be either hosted by you as a customer yourself or by partners. And this is actually also a great partner opportunity where partners can serve this the session border controllers to multiple customers. Also super important to remember, once you have decided to have your own SBC, when you configure it, follow closely the vendor documentation. The vendors document very well what you need to do to configure it, but we have seen a couple of customers doing misconfigurations, leading to some issues in their environments. How do we approach all of this? Well, first we'll talk about what direct routing is and when to use it. Then we'll talk a little bit about the architecture and the flows. After that, we go into planning and configuration for direct routing. And finally, we'll talk about how to manage direct routing. So, direct routing, what is it and when should you use it? Let's just start very briefly with Enterprise Voice for the cloud. What you can see right now on the slide is Microsoft Teams and Office 365, our hub for teamwork. And we can add the phone system. It's an additional license or included in some of the licenses. We'll go into detail a little bit later, but phone system gives Microsoft Teams PBX capabilities. What we don't have at this point is any connectivity to the actual phone system. And there are two options, either the Microsoft calling plans, where Microsoft provides you a phone number, or direct routing in Teams. In this session, we're going to concentrate only on direct routing. Just for the context, it's important to understand that if you want to give your users phone numbers and they should be able to call phone numbers, you need to have Microsoft Teams, the phone system, and then one of the two options, Microsoft calling plans or direct routing. Let's take a closer look at direct routing for Teams. In the lower right corner, you can see a user being connected to Office 365 using the phone system there. Over the internet, now the phone system is connected to a certified session border controller. This session border controller in turn could be connected to any third-party PBXs, any existing phone system that you have. It could be connected to an analog telephony adapter, so if you need to connect any analog phones. And then the session border controller is connected to a PSTN trunk. This could be a SIP trunk or a traditional PSTN trunk, but that leads to the PSTN network. And that means now if a user wants to place a call, we have here the connection via the phone system to the session border controller to the PSTN network. Don't worry, we'll go into more detailed flows on signaling and media a little bit later in this session. Let's take a look at the customer example, how they are going to use direct routing and combining it with the Microsoft phone system. So in the example, Contoso is a multinational company and they have users in the USA, in the Netherlands, and in Austria. Contoso is absolutely sold on the value of Teams and they want to make it the calling endpoint for the users. They want to get rid of all their old telephones, well, as much as possible at least, and enable users to send and receive their phone calls from the Teams clients. Additionally, in the Netherlands, Contoso has a call center. The call center users will, at least for the time being, remain on the existing PBX. So how should Contoso, or how could they approach this scenario? So the users are located, said, in the USA, in Austria, or the Netherlands. First, they need to look on where are calling plans available. Calling plans provided by Microsoft are only available in a selected number of countries. The USA, they have calling plans, Austria doesn't, and the Netherlands do have calling plans. Then the special considerations, none for the USA or Austria, but there are special considerations for the Netherlands. They have this integration with their existing PBX for the call center users. So what are they going to do? So for the USA, they just go with calling plans, because calling plans provide them everything they need and they don't need to have any local equipment. In Austria, there are no calling plans, so that's where they are going to use direct routing. In the Netherlands, they want to do both. They are going to combine the phone system. So for all the users that are on Teams, they will get phone system, but they will also provide direct routing so that when a user on Teams calls a user who is still on the PBX, that this can be directly routed via the session border controller and doesn't need to leave their network. And this leads us directly into the benefits of direct routing. First, we have this interoperability with third-party systems. You have a PBX on premises, you still need to use it for some reasons, maybe just for a subset of users, no problem. This shouldn't block the rest of the users. If you have direct routing, you can route your Teams calls directly to this on-premise PBX and get sure that users from one system can call the other users. Also, you can leverage existing contracts with service providers. Let's say you just signed a new contract with a PSTN provider and they give you really good rates for national and international calling. Well, no reason that you get completely rid of them. You can still use them. Just get sure that you have the session border controller, you have direct routing, and that all the calls are terminated on Teams clients so that users can use Teams while they still benefit from your existing contract with the service provider. In Teams, if you have phone system, if you have telephony, every user will get a DID, every user will have a phone number that can be directly called. You can use direct routing in any country where calling plans are not available. If Office 365, if Teams is available, so is direct routing. As shown in the example before, direct routing can be combined with calling plans. So you can choose if a particular call should go via calling plans or via direct routing. And there's less hardware footprint if you look to Skype for Business. In Skype for Business, we had a similar solution. It was called Cloud Connector Edition, but it required you to run virtual machines on some Windows Server hardware. And here, all you need to have on premises is a session border controller. And there are also options how partners can host these session border controllers on your behalf. So ultimately, you can do it without any hardware that you need to run or maintain yourself. Some additional direct routing considerations around service numbers. Service numbers are special phone numbers used for services in phone system. If you're using call queues, auto attendant, dial-in conferencing, then you need to have a service number. They are designed to handle a high concurrency of calls. It's important to understand that today, these service numbers can only be provided by Microsoft. So you cannot use a direct routing number as a service number. You need to use the number that Microsoft provides to you. If you want to use your own numbers, you can consider porting your number to Microsoft so that you can still keep this number, but it will be serviced by Microsoft. Another consideration, if you have configured Skype for Business Hybrid, users need to be homed in Skype for Business Online, otherwise they won't be able to leverage direct routing. So now that we know why direct routing is great and why we want it, let's take a look at the flows. Let's start to look at signaling. In this diagram, you can see the different networks. Here on the top is the Office 365 network, a worldwide network run by Microsoft to effectively deliver Office 365 services in high quality to our customers. Then we have here the internet, users using Microsoft Teams from outside your corporate network, and then we have here your corporate network with users using Teams from inside your corporate network. We have here a user outside the corporate network, we have a user internal to your network, then we have here a session border controller, and then we have here a PSTN next hop. This could be a PBX or just a SIP trunk or a PSTN trunk to your phone provider. So the signaling will always travel to Office 365 to a component called controller, and it doesn't matter if a user is internal or external, the path will always be the same from the user or between the user and Office 365. It will also travel between the user and the session border controller. However, the session border controller will talk to a component that is called SIP proxy in Office 365, and this component will talk actually SIP to your certified session border controller. Ultimately, the session border controller and the PSTN next hop will exchange signaling directly depending what your PSTN next hop is. Now, let's take a look how the media flows. The media is the actual audio that needs to flow from your users to the session border controller. Please note that this slide is talking only about the media flow without any media bypass. Media bypass is a feature that is not available yet to customers. However, we are testing it and expect to ship it soon. As soon as it's available, we will update this training so that you can learn all about the media bypass. But this is what is happening today. Just as in the previous diagram, we have our three networks and we have our internal user and our external user. So the internet user sends all the media to Office 365, to a component that's called the media processor. Please note that this traffic is not sent over the public internet. Well, at least most of it is not. It will send the traffic between the user over the public internet to the next entry point to the Office 365 network. We have worldwide a lot of different Office 365 networks, and depending on what internet provider the end user is using, this might be very little or a couple of hops to go to the Microsoft Office 365 network, but as soon as the traffic is on the Office 365 network, it is on this highly optimized, high bandwidth, low latency, no jitter, no packet loss network that will provide great quality to your audio calls. As said, Office 365 network is optimized for Teams traffic. Very similar for internal users is exactly the same. From the corporate network, it will go over the internet to the Office 365 network. Since this is a network, the corporate network that you manage, hopefully you have optimized your access to the Office 365 network and you can go as direct as possible. If not, then you might want to work with your internet provider to figure out how you can optimize this connectivity. We are also going to release a training on networking that will help you to better understand how you can optimize this media path. These media processors are located in our data centers in North America, Europe, and the APAC data centers. So this is where we process the media and then send it to the session border controller. And here again, over the Microsoft 365 network, we go as closely as possible to the location where the session border controller is located. Then we go a very short leg over the internet, and then we hit the session border controller. Because this is, again, on the corporate network and you control the corporate network, you can work with your internet providers to optimize the network path between your corporate network and the Office 365 network. Then from the Office 365, from the session border controller, the media flows to the PSTN next hop. In the voice routing section, we'll talk about how users can dial phone numbers and how the system decides where to route the call to. Dial plans are about how users dial phone numbers and how they are normalized to a format that the phone network can understand. The phone network expects phone numbers always in the E164 format. So, for example, a US phone number would be +1 555 123 4567. But that's not how users dial phone numbers. Most users will just dial, well, if they are located in the US, they will just dial 555 123 4567. So there are built-in rules as part of a dial plan that will normalize this number and fit it to the expected E164 format. Teams has built-in rules for the most common normalization rules. However, customers can build their own rules to allow either short digit calling for internal calls or just not require users to dial local area codes. For example, if the user in this example is in an area code 555, then probably they just want to dial 123 4567. Now the system needs to know that this user is in this area code and prefix the right phone numbers. So you would create a custom normalization rule that's for all then assign it to all the users in this particular area code, and then they could just dial the number as they are used to. However, as part of this training, we will not go into any details on how you can create custom dial plans. So once a user has dialed the number and the number has been normalized, how will Teams deal with this number and decide how to route it? In this example, a user from Germany makes a call to +1 800 642 7676. So the first thing that the system will check, is there a voice routing policy existing for this user? If not, then it means this user can't use direct routing and will have to fall back to calling plan. If there is no calling plan for the user, that means, well, the user has neither direct routing nor a calling plan, so the call will fail and the user can't place the call. If there is a calling plan assigned to the user, then the system will check, is this a domestic or international calling plan? If it's domestic only, this call will fall again. Why? Because this is a German user and the call to +1 is a call to the US. So this would be an international call for this user and this call will fail. If the user has an international calling plan, then this call will flow via the Microsoft calling plan. But if the user has actually a voice routing policy existing, means this user is a user for direct routing. Within this voice routing policy, there are different PSTN usages. They are evaluated in order, and each of these usages can have multiple routes. So now the system is looking first, does the user have a voice routing policy and what are the PSTN usages? If there's no match, it means that this user doesn't have any voice routing policy that allows him to dial this phone number, then we go back to the check if the user has a calling plan, and then the call will either fail if there is no calling plan or if there's just a domestic one, or the call will succeed via Microsoft calling plan if there's an international calling plan. However, if in the voice routing policy there's at least one route that matches the dial pattern, then the call will be tried via the SBCs that are in the route. So each route can have multiple SBCs for load distribution and failover reasons. If this succeeds, then the call will be placed via direct routing. If all of the SBCs are not functional, because they are down for maintenance, then the call will fail. So how can you plan for direct routing? There are a couple of important steps that you need to be looking at. First, do you even want to host the SBC yourself, or do you want a hoster to run the SBC for you? You need to look at the licenses that you need for direct routing. You need to evaluate what session border controller to use. You need to configure an FQDN for certificates. You need to configure your firewall. You need to think about if you have just a single SBC or multiple. And if you are someone who is actually a partner and wants to host SBCs, then we have some information on how that can be done. Self-deployed versus hosted SBC. Direct routing allows for a hosted SBC model. That means a partner can offer an SBC to multiple customers. They just need a single certificate per SBC, need a single IP address for SBC. So this is a solution that scales very well for multiple customers. And there are a lot of benefits for the customer, but also some disadvantages. Basically, the benefits is if you deploy your SBC yourself, you have full control over it. You can do whatever configuration you need, whenever you need, connect to your existing PBX, but you are also fully responsible for this SBC. So you need to have a location to host it, you need to run updates, you need to maintain it, you need to purchase it, etc. So from a cost perspective, it might be beneficial to have a partner who hosts it for you. So if you have a partner hosting the SBC for you, you don't have any environment, any equipment at all on premises. All your PSTN services come from either Office 365 or this partner hosted SBC. They purchase the SBC, they maintain it, they configure it, which reduces a little bit the control that you have and makes the support model a little bit more complex. Because now, if there's any quality issue or any connectivity issue, you don't have visibility yourself to all the components, but need to work with the partner in addition to working with Microsoft. Please note that when you're working with the partner, that there's currently no certification program from Microsoft. So any partner can just offer this service to you, but Microsoft is not requiring to pass any tests or do any quality checks. They can just move forward and do that. So be sure that you understand very well the cost structure, how much they are going to charge you for this service, the support process, how you can escalate any problems and how they are going to work together with Microsoft, the partner architecture, so how they're using the SBC, if they're using an SBC that is fully qualified by Microsoft, and do some tests if the quality meets your expectations. When it comes to licensing, obviously you need to have a license for Teams itself so that the user can use Teams. Then you need to have the license for the phone system that provides the phone features to your users. In E5, it's already included, and you can get it as an add-on for E1, E3, and E4. Optionally, you want to get a calling plan. It's an add-on to the phone system, and it allows you to use, as we've seen in the examples before, calling plan in addition to direct routing. Also optional is the audio conferencing license. The audio conferencing license is required if you want to add a PSTN phone number to an existing call. So you're already calling a user either from Teams to Teams or from Teams to a PSTN number, and you want to add to the same call a third user on a PSTN number. Then you will have to, the user needs to have the audio conferencing license. The Session Border Controller, the SBC. It's the piece that connects Teams to the PSTN next hop, being your existing telephony system or telephony trunks that you get from your provider. There is a certification process where Microsoft validates the SBC with a third-party lab to get sure that it can interconnect with Teams and has the right features and will provide the right level of quality. We test all certified devices daily in a pre-production environment on automated tests so that we can ensure that if we make any changes to our service, the SBCs continue to work. There's a joint support process with the SBC vendors. So if you have any issue with your direct routing and you need to get support from Microsoft, we have a joint process with the SBC vendor. At the moment, we have 3 validated partners, AudioCodes, Ribbon Communications, and ThinkTel. An up-to-date list of the supported SBCs, the vendors, and the models that they have, you can find at aka.ms/dr-sbc. Microsoft communicates to the SBC via the FQDN. So you need to have a fully qualified domain name so that Microsoft can locate and find your SBC. It's important that the domain of this FQDN is registered with Microsoft. That means you cannot use an onmicrosoft.com domain. it's not supported for SPC names. You need to have a vanity domain. So for example, if you use contoso.com as the DNS name that's registered in Office 365 tenant, then you can use, for example, the following names: spc1.contoso.com, us spcs15.contoso.com, whatever you want.contoso.com. What you cannot do is adding another subdomain. You could not do spc1.europe.contoso.com. Well, you can if you register the domain name europecontoso.com in domains first. Registering a domain is not very difficult, and we don't have all the details here. If you need to have the details, just go to ak.ms/add-domain. But it's basically in the Office 365 administration portal. As a global administrator, you go to the domain section and then you add a domain. Then it will ask you to create a specific domain record, which basically proves that you are the owner of the domain. And because you can make this change to the domain record, we know that you own it and can verify you. Once you have added the domain, now you can use that domain for your SPC names. The certificate is used to validate the identity of the trusted SPC. So you have your FQDN of the SPC, and there's a certificate that proves that this is really the server it's supposed to be. This certificate is signed by a trusted certification authority, so only you, because you have the certificate, can own this domain name, and only you have the server that runs in that domain, so we can trust this SPC. If you have just a single SPC, well, then you just put the name of the SPC in the subject name and you're good to go. However, if you have multiple SPCs, there are different scenarios how you can design your certificates. And depending if you want to minimize the certification cost or if you want to maximize the security, you have different options. So for the sake of the example, you have 4 different gateway SPCs. You call them gateway1.contoso.com, gateway2, gateway3, gateway4.contoso.com. In the scenario where you want to minimize the certification cost, you put one of these gateway names in the subject name, and then in the subject alternate name, you just put *.contoso.com. You're using a wildcard certificate. And now this certificate can be used on any of the other SPCs that you're using, because all of them are matching this certificate, this wildcard certificate. They have some dedicated part, but then there's .contoso.com. Or you could use a single certificate with multiple subject alternate names. So in this example, the subject name is gateway1.contoso.com, and then all the individual servers are also listed in a subject alternate name. Please note that if you ever decide now I want to have gateway5.contoso.com, you need to change your certificate or get a new certificate. So these more secure options also reduce the flexibility that you have. Then the maximum security scenario, you have one certificate per server. You dedicate this one certificate for all your servers. So the first SPC gets gateway1.contoso.com, the second one gets dedicated certificate gateway2.contoso.com, and now you have multiple certificates that you're going to use. You can find a list of all the supported certificate authorities with the link shown on this slide. When it comes to IP ranges and ports that you need to allow on your firewall, please note that the SPC requirements are different from client requirements. So clients will need to talk to different FQDNs and use different ports. What we can see here on the slide are just the requirements for the SPC. The SPC itself can have a public IP or can be behind the net. For the firewall configuration, 2 things are important. One is the SIP signaling that happens between the SPC and the SIP proxy, the SIP proxy being this component in Office 365 that the SPC can talk to via SIP. The on the SIP proxy side are pre-configured by Microsoft. You can see them here on the slides. The SPC ports, this is something that you need to configure on the SPC, and the different SPC vendors provide guidance on what you should configure. The IP addresses, well, the FQDN and IP addresses for the SIP proxies, you can see them also here on this slide. And please note that no matter in which location you are, the SPC needs to be able to talk to all of these locations. In case that we have ever an outage and it, for example, cannot talk to a Europe location, then it will fall back to the Americas or Asia. For the media ports, same principle. You can see here the ports that, in this case, the media processor needs to talk to the SBC, and the SBC will talk to the media processor. The SBC ports are defined on the SBC, and for the media processor ports, you can see the ports here on this slide. Also, the media processors are in the IP range that you can see here on this slide. So from an from a port perspective, IP perspective, these ports need only to be open to this one range of IP addresses. So you can get sure that your SBC will talk only to this trusted networks on these specified ports. And we highly recommend, for security reasons, to configure your firewall that the SBC can indeed only talk to these ports and IP addresses. You can leverage multiple SBCs to provide low distribution, high availability, and disaster recovery. If you have multiple SBCs in the same location, you can just group them within a single voice route, and the load will be distributed between them. And if you need to take down one of the SBCs for maintenance, or if you lose one of the SBCs for whatever reason, the load will be just distributed to the others, assuming that they can handle the full load. Depending on the SBC vendor, you can also cluster multiple SBCs, and they will appear to teams just like a single SBC. If you do it like this, then the load will be equally distributed between these SBCs. Sometimes there might be situations where you want to prefer a specific set of SBCs and just use others for backup. You can do that by configuring multiple voice routes and having priorities assigned to these voice routes. And if no SBC is available to take a call with the highest priority, the next voice route with the next highest priority will be used. And this way you can fail over to other SBCs if you need to. Disaster recovery, this is very similar or uses the same concept, but here we are thinking more of a scenario where, let's say, you lose all your SBCs in the US, but you want that your most important users can still place calls by using the SBCs that you have placed in Europe. So you can configure voice routes that are only assigned to the users that should be able to do these calls. So again, you lose all the SBCs in the US, but for the users who have these routes assigned, they can still use the SBCs in Europe and place their calls. This slide is about how SBCs can be used for multiple tenants. So how one company, partner, a hoster, a carrier perhaps, can use one SBC, or well, actually multiple, and use them for multiple customers. There are two parts to it. First, there's the hoster configuration, and second, there's the customer configuration. In the hoster configuration, obviously, the hoster needs first to deploy and configure the SBCs. Then they need to register a domain name in the hoster tenant. In our example, they will use customer.adatum.com. Now they're going to request a wildcard certificate, *customer.adatum.com, so that any subdomains that we are now going to create for each of the customers will match against that certificate. And now we're going to register subdomains for every customer. So for the first customer, we will register customer1.customer.adatum.com, and this will match against the wildcard certificate. It's also important that you activate this domain by adding at least one user in the hoster tenant with matching SIP address. So that will be dummy user at customer1.customer.adatum.com. Then you can use this as an FQDN, this SIP domain as an FQDN with the customer subdomain for your SBC, customer1.customer.adatum.com. By the way, the hoster tenant, it's not a special tenant, it's just a regular tenant. We're referring to here to it as the hoster tenant because it's the tenant the hoster is using. On the customer side, the customer needs to register and activate the subdomain in the customer tenant. So they need to go into their admin portal and add customer1.customer.adatum.com. And then they just go ahead and configure the trunk from the hoster to the customer tenant. Let's look at an example. So here at the bottom, we have a datum, and the datum is our carrier or hoster tenant. Again, just a regular tenant that's used by the carrier or hoster. They have their default domain, adatum.biz, and they add additional domains, the additional domain for all their customers, customer.adatum.biz. And now they have 3 customers, Woodgrove Bank, Contoso, and AdventureWorks. So for each of these customers, they're creating a new domain, sbc1.customer.adatum.biz, and this is the domain that the customer will be using to create the to add the SBC to their environment. sbc2.customer.adatum.biz for Contoso, sbc3.customer.adatum.biz for AdventureWorks. And as you can see here very clearly, now Adatum can use this single SBC with a single certificate for multiple customers. Obviously, they want to deploy multiple SBCs to provide the right service to the customers, but they can do this with a single certificate, which means that the solution scales very well. Having completed all the planning steps, we can now go into the configuration for direct routing. The SBC configuration includes a number of steps. You need to configure the SBC license, you need to configure the LAN and WAN IP interfaces, the certificate on the SBC, the signaling and media ports. Very important, you need to configure TLS 1.2. Since we're enforcing that now on Office 365, we're seeing a couple of customers who are trying to use TLS 1.0 or 1.1, which will lead into errors. SIP options and SRTP need to be configured. You need to configure the connection to the PSTN next hop. We will not go into detail because all of these steps depend on which vendor you're using for the SBC, but you can find here on the slide a link to the SBC vendor configuration. They provide detailed step-by-step documentation on how you can configure the SBCs. So now your SBC is configured. Now you need to pair the SBC with your environment. There's a very simple PowerShell commandlet that you can run or that you need to run. It's the new CS Online PSTN Gateway, and you provide an FQDN, 6 signaling port is configured on your SBC, maximum concurrent sessions, and a number of other attributes. And we'll go into these other attributes over the next slides. You can run the new or set CS Online PSTN Gateway with the following parameters. The SIP signaling port defines the SIP signaling port on the SBC. So whatever you configure on the SBC as a port to listen for signaling, this is what you need to configure here as well. The enabled parameter allows you to put the gateway actually in a disabled state where no new calls would be put to the SBC. However, incoming calls will still be accepted. So if you want to drain, for example, your SBC, you want existing calls to continue, but no new calls being placed to the SBC, you can set enable to false, and no Teams users will put new calls to the SBC. And once you don't have any calls on the SBC, you can turn it off or update it or do whatever you need to do. Since this is valid only to the Teams side, you need to get sure whatever your next hop on the PSTN side is also is aware that you want to drain the SBC and doesn't send any new calls to the SBC. The forward PII is the P-asserted identity, and that can be used for billing purposes. The default value, however, is false. The forward call history is history information about call forwarding and can also be used for billing purposes. The default value is also false. SIP options enabled allows the SBC and Teams to communicate to each other and send SIP options to learn if the SBC is available or not. It's highly recommended to have the SIP options turned on. If you turn it off, then the Teams might not be aware that a certain SBC is not available. The maximum concurrent sessions is a parameter that we use in our alerting system. You set a value on how many sessions the SBC can handle, And if we ever reach 90% of that or a higher value, then an alert will be created. The fast failover timer is used to detect if an SBC is not available and fail over to another SBC. However, we have seen cases with slow networks where, because of the slow speed of the network, we thought that an SBC was offline, failed over to the next one. If you are in such situation, well, we would prefer if you improve the network, but if you can't, consider to disable the fast failover timer so that we will continue a little bit longer to see if an SBC is responsive. For the user provisioning, we are here considering these two cases, one where you have only direct routing for a user configured, or where you have direct routing and calling plan configured for a user. In both cases, you will need to have a Skype for Business Online Plan 2 license, you will have to have a Microsoft Phone System license and a Microsoft Teams license. Additionally, for the calling plan, you need to have the calling plan license. The phone number is configured depending on what system, what option you're using. If you're using direct routing only, the phone number is configured in the on-premises or Azure Active Directory. If you're using Microsoft Calling Plan with direct routing, then the phone number comes from either Microsoft or you need to port your phone number over to Microsoft, but it is hosted by Microsoft. The routing, in direct routing only, the administrator configures the route and only these routes are evaluated. If no route is found, then calls will drop. If you have mixed the calling plan and direct routing, then first the routes configured by the administrator are evaluated if there is a direct route to be used by users. If not, if there is no direct route, if there's no route configured, then we will fall back to using the calling plan. And this is something that we have seen earlier in the session on the list on the number routing. Next, we need to configure the call routing. So we have here a couple of concepts that help us to configure which users can dial which kind of numbers and how they are routed. First, each user has exactly one voice routing policy that will define what this user is allowed to call and how the call is routed. A voice policy can include one or multiple usages. These usages are used for different scenarios. So depending on your requirement, let's assume this is a US-based company, they create a usage for national calling and a different one for international calling. And then they can assign some users a voice routing policy that has only the national usage. These users will only be able to do national calls, and other users will get both the national and the international calling usage, so they can dial all kinds of numbers. Obviously, this is just an idea, but you can create multiple different usages for premium numbers or any other scenarios that you want to configure in your environment. Each of these usages can include one or more voice routes. So the voice route would, and we are explaining in a second what the voice route is, but all voice routes that allow national calling would be added to the usage for national calling, while voice routes for international calling would then be in the usage for the international calling in our example. Each of these voice routes define a number pattern to match against the dialed phone numbers. So if a user dials a phone number, we look into the voice route and see if this phone number matches the pattern and if this voice route can be used. It defines to which SBCs the call should be routed if it matches the pattern, and which usages can leverage the voice route. So, example again, the voice route will be used to define certain route for all numbers that start with +425. They should be rated to the gateway in Redmond, because this is actually the Redmond or Seattle area code. And this should be linked to the national usage so that if a user has a routing policy, including the national usage, they can leverage this voice route whenever they dial +1425. Another important concept is that SBCs can be part of multiple voice routes. So we can here have an SBC in in this particular voice route that we just talked about, but then it could be also used for another voice route. And that gives us the flexibility to really configure the routing in a way it matches the requirements of a company. Let's look at an example of a simple configuration. In this example, we will have only one gateway, and we will route our calls via this one gateway. So first of all, we need to start creating that gateway in our system. So we use the new CS Online PSTN gateway, and we're using here the minimal set of parameters to define that. We are configuring the FQDN of the gateway, the SIP signaling port that's configured on the SBC, and then we're setting it to enabled true so that it can be used for outgoing calls. Then we create this PSTN usage that we are going to be using. We're here just taking a simple approach, so it's an unrestricted PSTN usage. Users will be able to call all numbers. That's why we're calling it unrestricted PSTN usage. Please note that we're using here the commandlet set PS online PSTN usage and the identity global, because there is actually only this one container, and into this container we are adding these components, for example the unrestricted PSTN usage, and then we can assign that to users. Now we're doing a voice route. We create this new CS Online voice route. We give it an identity, we call it unrestricted voice route. The number pattern is .*, so that's the regular expression to accept really everything. So any number dialed will be matching this route. Then we provide the gateways, the SBCs, so online PSTN gateway list is sbc1.contoso.com. We assign it a priority, 1, highest priority, and then we link it to the online PSTN usage, unrestricted PSTN usage. So if someone is allowed to leverage the unrestricted PSTN usage, now they will be able to use this voice route. Next, we need to configure the voice routing policies. And this is really where we link now the user to the PSTN usage. So first we need to create it, new CS Online voice routing policy. We call it unrestricted voice route policy, and we link it to the online PSTN usage, unrestricted PSTN usage. This means now every user who has this voice routing policy can leverage this PSTN usage of unrestricted PSTN usage and all the voice routes that are included in it. Now we need to grant it to the user, so we run grant CS Online voice routing policy, identity of the user is Spencer Lowe, and the policy name that we want to grant to the user is the unrestricted voice routing policy. Now this user can dial any number and it will be routed via the SBC1. Let's take a little bit more complex scenario. In this case, we are going to have 6 SBCs in 3 different locations. So let's start with the first 2. As in the previous example, we use new CS Online PSTN gateway and we register these 2 SBCs. We create our first PSTN usage. We call it US and Canada usage. Now we configure voice routes. So voice route for +425 and +2106. Both of these are Redmond or Washington area codes, and we want to route them via the Redmond 1 route. In the Redmond 1 route, we have these 2 gateways, SBC1 and SBC2, priorities 1. That means if now a call matches this pattern, all calls will be distributed between SBC1 and SBC2. However, we have here a second set of gateways, SBC3 and SBC4. We give them the same route. So, we give them the same number pattern and create a new route for that. So, new CS Online voice route, identity Redmond 2, number pattern is the same. We add SBC3 and SBC4 as gateways, but the priority is 2. The online PSTN usage is the same. Now we have these 2 sets of gateways, and if the gateways in the higher priority route are available, they will be used, so all calls should go to SBC1 and SBC2. However, if for any reason these are not responsive or not available, SBC3 and SBC4 will receive the calls. Now, even more gateways. The SBC5 and SBC6 are added, and we are adding now another route. And this is really for any other calls. So we call it any other calls that start with +1. So we call it other +1. We provide a number pattern for the +1 calls. We add the gateways SBC5, SBC6, and put it into the same online PSTN usage. Now we create the routing policy, link it to the PSTN usage, and we grant this routing policy to our user Spencer Low. So now our user will be able to call any +1 numbers. They will be routed to either to, well, depending on what exact number the user dials, they will be routed accordingly. So if it's a number starting with +1, 425, or +1, 206, they will be going to SBC1 and SBC2. If these two gateways are not available, they will be going to SBC3 and SBC4. And if those are not available, they will be going to SBC5 and SBC6. And so will any other numbers that have that start with +1. As you can see here also, the system knows that SBC5 and SBC6 should only be used for +1, 425 and +1, 206 numbers if all the other gateways are not available, because the priority we assigned is the priority 3. Now, let's look how we can manage direct routing. Let's use this simplified view to understand how these different components can be supported and who is involved. So if we're looking here between the user and the SBC, then you need to look into the call quality dashboard. It's a tool in the Teams admin portal that provides you an aggregated view on the quality of all your calls in your environment. And you have the call analytics where you can look into individual calls. On the SBC, you also have SBC logs. And if you're interested to troubleshoot the SIP traffic, the signaling between the SBC and Teams, then this will be the best place to look into these logs, because they are very easily accessible on the SBC directly. If you have your SBC connected to a PBX, then you might want to look at the PBX logs in case you have any difficulties on calls between Teams users and PBX users. And then finally, if you have troubles on calls to your PSTN, you might want to look into the connection to the PSTN and see if any problem is there. On this slide, we have collected a number of common SBC configuration issues that we have seen. On the left side, you can see the symptoms. On the right side, you can see the common solution. I will just walk one by one through these known issues or common issues. If you're seeing TLS errors on your SBC, most likely you haven't configured the SBC for TLS 1.2. Office 365 is enforcing the usage of TLS 1.2. We are not accepting any connections on 1.0 or 1.1 anymore, and this leads to exact that error. If for your options being sent out from the SBC, you're not getting back any 200 OK, that usually indicates that there is either a missing root certificate chain, so they don't trust each other, or a firewall misconfiguration. So you want to double check these configurations. If you're seeing a failed to verify peer certificate error message, that usually indicates that the Baltimore root certificate hasn't been imported on the SBC. If for your options you get back a 403, provided trunk FQDN is not allowed, it means that most likely the contact header has not been defined on the SBC. So whenever the SBC communicates with Office 365, Office 365 is expecting all communication to come from the FQDN that you have configured. If you haven't set up this FQDN on the SBC, or maybe there's a typo in it, you will see that error message. In case you see transfer fails with 603 messages declined from the SBC, that usually means the refer support has not been enabled. For cases where calls connect, but you can't hear any audio, and then shortly after the call disconnects, most of the time that indicates a net traversal issue. So you have placed your SBC behind the netted IP, but the SBC needs to be aware of that so that it can send out the correct IP. So please check this configuration and fix it if there are any problems with it. Outbound caller ID anonymous. Example here would be a Teams caller calls the user on their cell phone. On the cell phone, they don't see a call ID, it just says anonymous. This could indicate that you set the forward PAI to true, and now the SBC, before it sends the call to the next PSTN hop, strips all of the information around caller ID. This can be fixed with a few additional configuration steps on the SBC, and you might want to check the SBC configuration guide to figure out how you can do that. For incoming calls from the SBC to Teams, if you see a 404 not found, that means that Office 365 wasn't able to find this phone number. So you need to check, first of all, is this phone number even supposed to be assigned to a user on Teams? And if so, have you configured this phone number correctly in Office 365? Does it have the correct number formatting? If all of your outbound calls are failing for some users, that usually indicates that the dial plan includes some regular expressions for one or more rules that are invalid. And even if this specific rule is not used for that specific call, you might still see the outbound calls failing. And now the summary. Let's just reiterate the 3 most important points. If you don't remember anything about this session, just take the following 3 things with you. Direct routing allows you to use your existing PSTN connectivity to provide PSTN capabilities to your Teams users. The session border controller can be either hosted by a customer themselves or by partners who are doing SBC hosting. When you configure your SBC, follow closely the vendor documentation to get sure that you don't miss any of the configuration steps. This concludes today's session. Thanks a lot for your attendance and see you next time.